Hello, everyone. Today, Jason and I discuss NVIDIA in great depth, going beyond just the hardware moat and getting into the crux of the matter, which is in fact a software moat. This is a companion piece to the TechIQ Substack posted on February 6th, 2025. This podcast was recorded on February 7th, 2025.
Okay, Ophir, I know you love this subject. Today we are going to cover NVIDIA.
Honestly, Jay, I love this subject. Maybe let's start with a simple explanation of what NVIDIA does, and then we can get a little crazy with technical details and why they matter. Because they really do.
Challenge accepted. All right, imagine this. You've got a homework assignment with like 1,000 math problems. Feels impossible, right? Now imagine you've got a magic calculator that doesn't just do one problem at a time, but all 1,000 problems at once.
That sounds like some sort of math wizardry. I would have loved that back in school.
Exactly. That's basically what NVIDIA's GPUs are. Think of them as these supercharged calculators designed to solve ridiculous amounts of problems at once, and not just math problems, but the really challenging ones like teaching computers how to drive cars or talk to you like a chatbot does.
Yep. It's not just doing one fancy trick at a time, it literally tackles millions of problems all at once.
That's right. A regular computer or CPU is like one really smart kid in your class doing all the problems on their own, step by step. But NVIDIA's GPUs are like the entire class, thousands of students all solving parts of the assignment at the same time.
Oh, I love this analogy. So it's like, instead of one kid burning out after hours of work, you've got an army of mathletes handling everything together at top speed.
Exactly. That's why these GPUs are so powerful. They're not just doing graphics anymore, they're handling everything from AI to medical tools. It's all about solving big problems and doing it insanely fast.
Okay, Jason. Building off what we were just talking about, I call it the Great Transition. Did you know Nvidia made nearly 10 times more money from AI chips than from gaming chips in just one quarter last year? That's wild, considering just a few years ago, this was a gaming company first.
That's right. It's wild. Back in the day, NVIDIA's bread and butter was gaming GPUs. But now, AI data centers are their, main event. We're talking $33 billion from data center in a quarter compared to just $3.8 billion from gaming.
So gaming's still the origin story, but AI became this mega blockbuster stealing the show.
Exactly. And GPUs like the A100 and H100 are driving that shift. They're designed for heavy duty AI tasks, training massive neural networks, processing mountains of data, you name it. Gaming GPUs look kind of like little siblings in comparison now.
It's such a glow-up story. From humble gaming graphics to being the backbone of AI supercomputers. That's an iconic tech pivot right there.
Definitely. And it's not just the hardware. What really sets NVIDIA apart is CUDA. It's like their secret sauce, a programming platform that lets developers unlock the full power of these GPUs without breaking their brains. Think of it as a translator that bridges the gap between mind bending tech and practical applications.
Oh, I love this part. CUDA changed the game, right? It's why NVIDIA's sticky in the industry. If you're a developer and you've invested years building AI models on CUDA, guess what? You're not dumping it for the next shiny thing. It's just too costly and complicated.
Exactly. And that's why NVIDIA's software ecosystem has become just as powerful as their hardware. The combination of cutting edge GPUs and rock solid tools like CUDA creates a kind of moat around their business. You don't just need better chips to compete, you'd need a whole new ecosystem to even get started.
And that's what, like a decade-long head start NVIDIA's got? I mean, they're practically running a monopoly in AI infrastructure.
Well, it's more like they're the backbone everyone builds on, from AI researchers to cloud giants. NVIDIA's GPUs are in the mix everywhere.
And if the next ChatGPT or self-driving car is making headlines, chances are an NVIDIA GPU was behind the curtain making it all happen.
Yeah, CUDA really is the backbone of NVIDIA's dominance, and here's why. It's not just some piece of software, it's a platform, almost like a Swiss Army knife for developers using NVIDIA GPUs. It enables them to harness the raw processing power of the hardware without having to reinvent the wheel every time a new AI model or application is built.
Wait, let me guess. It's like giving developers a treasure map to all the hidden power those GPUs have.
Exactly. And over nearly 2 decades, developers have built billions of lines of code and entire ecosystems around CUDA. That makes switching to a competitor's platform next to impossible because doing so would mean basically throwing away years or even decades of investment.
I want to dive deeper on this for a second, Jay. I've developed code before and never once even thought of CUDA. I didn't even know it existed or mattered. You're an actual developer and computer scientist, and I can't ever remember you telling me that you were using CUDA, but you're actually riding on its coattails every time you code in Python or C#.
Right? Libraries like PyTorch and TensorFlow handle all the heavy lifting with NVIDIA's CUDA, a platform refined and optimized over decades. Most developers don't even realize that every major AI library is tuned to NVIDIA's ecosystem. With 80 to 85% of AI pros using Python and billions of lines of code built on the assumption they'll run on NVIDIA chips, you're reaping the benefits of relentless performance optimizations, whether you code in Python or C sharp. And while many may not notice the underlying work of CUDA, they'd quickly see if their code slowed to the point of being unusable. Imagine a decade of progress grinding to a halt if libraries or hardware moved away from NVIDIA.
Yeah, this is just so crucial to understanding NVIDIA as not just a chip maker that could be displaced with another brilliant design. If you switched away from NVIDIA GPUs, your code would run significantly slower. Not too long ago, a few extra milliseconds, say 10 versus 20, were almost imperceptible, and any trade-off that could cut costs by 30% was a no-brainer. But today, even a 5-millisecond delay in AI training or inference can mean the difference between a product that works and one that doesn't. A product that takes a month to train and one that takes a year. Remember, billions of lines of production code are built on the expectation they'll run on NVIDIA chips. This isn't just a performance edge, it's an unassailable moat. Developers would notice immediately if libraries moved away from CUDA or if the hardware stopped being NVIDIA, and that shift would essentially grind a decade of progress to a halt.
Yep. That's the moat in action. It's not just about a competitor with a better chip. It's about the whole history of AI built around NVIDIA.
It's like this cycle that feeds itself, isn't it? Developers stick with NVIDIA because CUDA's already the gold standard, which means NVIDIA's gear stays at the top of the game. I just can't emphasize enough how the software moat is so powerful.
Exactly. It's that virtuous cycle. More tools and libraries are built for CUDA, which makes it even easier for the next developer to jump on board. And good luck to anyone trying to break into this space. You're not just competing on GPUs, you'd have to rebuild the entire software ecosystem from scratch to even get in the game.
You know, I love the software moat, but I just want to be clear that, of course, NVIDIA has a hardware moat too.
Absolutely. I mean, NVIDIA's CEO has remarked that the very process of designing their next generation chips now relies heavily on artificial intelligence. In other words, NVIDIA's own AI tools are indispensable to its chip design process.
Yep. I think it was in a Forbes article where Jensen said that NVIDIA has been using AI to optimize chip layouts and improve performance, and even NVIDIA might struggle to innovate at the pace it does if not for its own AI.
This creates a self-reinforcing moat. Not only does NVIDIA deliver industry-leading GPUs, but its AI-powered design cycle makes it exceptionally hard for competitors to catch up. And it has the software moat we just talked about.
I mean, competitors like ROCm and OneAPI, they exist, right? But they're miles behind CUDA in terms of developer adoption and support.
Yep, that's the challenge. Even with solid hardware, they'd need a complete ecosystem to match NVIDIA's momentum.
And here's the kicker. It's not just about today's GPUs. Every time NVIDIA releases a new chip, CUDA is already there, ready to optimize all the shiny new features. It's like every step forward in hardware is instantly backed up by years of software evolution.
To really understand how NVIDIA achieved this incredible momentum with CUDA and GPUs, we need to rewind to 2010. That's when they introduced the Fermi GPU architecture, which was like planting a flag and saying, hey, GPUs aren't just for games anymore.
Oh, so this is where they started flexing beyond gaming. What made Fermi such a big deal?
Well, Fermi came with some pretty groundbreaking features. Error-correcting memory, essentially a backup plan for when your math goes haywire, and better scheduling. So GPUs could dive into heavy-duty scientific calculations. It was basically their debut moment in the supercomputing world.
Right, and then Kepler comes swinging in 2012. Isn't this the architecture that took GPUs from promising to, essential for AI?
Exactly. Kepler brought things like HyperQ, letting multiple CPU cores feed a single GPU simultaneously. It also introduced dynamic parallelism, so GPU threads could spawn new threads on the fly without needing CPU help. That was a game changer for deep learning.
And wasn't AlexNet the AI model that blew the doors off deep learning, trained on Kepler? That feels like a moment that changed everything.
You're absolutely right. AlexNet kickstarted the deep learning gold rush, and it wouldn't have been possible without Kepler's efficiency. Then Pascal and Volta came along and built on that foundation.
Oh, okay, I gotta chime in here. Pascal and Volta, those two are like the Batman and Robin of NVIDIA AI history.
How so?
All right, Pascal's whole deal was speed, introducing things like NVLink and half-precision math. Suddenly, you could train bigger models faster, and it was like AI research hit a turbo boost. Volta comes in shortly after, adding tensor cores. Those cores, they're like little AI ninjas, supercharging the exact math neural networks need.
Couldn't have put it better. Tensor cores were a seismic shift, dedicated to making matrix multiplications lightning quick, and AI workloads haven't been the same since.
I love how Volta just straight up declared, hey, we're not doing this halfway. We're building chips explicitly for AI.
And that philosophy stuck. By the time we got to Hopper and now Blackwell, the hardware is practically custom built for modern AI tasks like training these massive transformers. The same models powering tools like ChatGPT.
But they didn't stick to just GPUs, right? They diversified hard.
Exactly. NVIDIA introduced DPUs, their Bluefield line. Think of them as traffic cops for server data, handling network traffic, encryption, even virtualization, so the GPU and CPU can focus on compute-heavy tasks without any bottlenecks.
Oh, and Grace CPU. This has to be my favorite wildcard from NVIDIA lately. Who thought they'd go from GPUs straight to designing their own CPUs?
It makes sense, though. Grace is designed specifically for feeding data to GPUs at insane speeds. NVLink C 2C lets the CPU and GPU work together like they're a single unit, avoiding the typical slowdown you get with standard connections like PCE.
I mean, put it this way, if DPUs are traffic cops, then Grace CPUs are like, I don't know, turbo-boosted supply trucks. They keep the whole AI assembly line moving without a hitch. Wild stuff.
Absolutely. Combining GPUs, DPUs, and Grace CPUs creates a kind of trifecta for next-gen AI infrastructure. It's NVIDIA saying, hey, we're not just here to crunch numbers. We're building the whole ecosystem to get the job done.
And it's not just the hardware trifecta, GPUs, DPUs, and Grace CPUs, that tells the story. Companies like Meta, Google, Amazon, and Microsoft are weaving NVIDIA's tech into the fabric of their AI ecosystems, building entire workflows around it.
Right? I mean, Meta alone is on track to deploy over 1.3 million of these things by next year. That's insane.
It really is. And these partnerships drive innovation on both sides. NVIDIA's hardware gets refined based on real-world deployment feedback, while these companies push the limits of what their AI can do, whether it's training massive language models or optimizing recommendation engines.
And let's not forget the volume. When companies go that hard on AI, NVIDIA's revenue charts end up looking like rocket trajectories.
Exactly. But this dominance doesn't come without challenges. Take AMD, for instance. They're starting to nibble at the edges with competitive GPUs. And don't even get me started on Google's TPUs, their in-house solution designed to bypass NVIDIA entirely.
Oh, competition is heating up, for sure. But it's not just about rival chips, right? I've been reading up on some of these alternative computing methods like algorithmic advancements that minimize the need for brute force hardware power.
Right, there's a growing conversation in AI about efficiency rather than scale. Models like DeepSeek supposedly deliver top-tier performance with way less compute. If that type of innovation becomes widespread, it could shake up NVIDIA's grip on the market.
Okay, so if the industry finds ways to do more with less, then NVIDIA's strategy starts to look less invincible, yeah?
It's certainly a major risk. But NVIDIA's trying to stay ahead by branching beyond GPUs. They're now offering a full-stack AI solution, GPUs, DPUs, and proprietary Grace CPUs working seamlessly together.
Basically, they're saying we're not just here for AI's heavy lifting, we're building the whole dang assembly line.
Exactly. And it's a bold move. By owning more of the AI infrastructure, they're positioning themselves as indispensable to everyone building the future of AI.
You know what's wild? NVIDIA's gone from drawing amazing video game frames to literally building the backbone of modern civilization, or at least digital civilization.
Honestly, it's an incredible trajectory. And while the future's uncertain, NVIDIA's been remarkably adept at anticipating where the tech industry is headed. Now, there's one last thing I did want to touch on, Jay.
I think I know where you're going, even with all the moat stuff we touched on. Nothing is forever.
Yeah, I just want to point out that there are some exciting developments happening in the private company world surrounding inferencing chips.
Right? So lay your armor, shield, and your sword down in the war for the best training chips, but there may be an opening for inference.
Exactly. Private firms are testing new chip designs which already assume the CUDA moat is maintained. But They are iterating on chips that are faster and less expensive for inferencing on these giant generative AI models that exist now and will exist in the future.
It's true, or at least it's possible. And in fairness, inference could be half of this total AI market in the future.
Exactly. So Nvidia is a marvel, but technology moves fast. Just be aware of risks. I'm sure Nvidia is.
Well said. All right, on that note, I think we're good to wrap it here. This was a blast, diving into NVIDIA's journey from gaming graphics to AI world domination.
Absolutely. Thanks for tuning in, and we'll catch you next time for another deep dive into the world of tech. Take care, everyone.